Okay, this is Joshua Taylor coming to you from here in Prince Edward Island. I'm looking forward to going back to Edmonton, Alberta. Been here all the winter. The first time I think I ever that I took taking the winter off of work. But today I'm coming to you on my next upgrade of the joepipe technology. And before you can see that I drew up the schematics of the joepipe heater, which makes up the main element, the 1.5 by 16-inch element, and this is your water plenum. So what I've done is I've actually went and had this pipe made up. This is 24-inch, schedule 40 black pipe, and it's, as you can see, it's threaded both ends. And if you were looking at the joepipe from the end, that's what it would look like that. And so this is on the table. It would actually be sitting down like this. This is the outside. So I decided to make this hexagonal instead of square. And the green that you see inside, that is your water plenum. And what I'll be using is 3/16 plate steel. I'll be picking up the pieces on Friday. It's Wednesday, then I need to find a welder that can actually pressure weld the system together. All right, I want to take this piece of tape off here. If you can see it, I did have it wrapped evenly around, right? So what I did, I wrapped it around and I cut it, and I'm taking it off. And the reason is, if you measure this out, okay, you have got a tape on the ruler. You got precisely 6 inches of element or steel, of schedule 40 steel. When you roll it out, it gives you that width. So you time this by 16 inches, and you get this here. This is it. You're actually your heating element. If you take the pipe and roll it out, 6 inches by 16 gives you 96 square inches at approximately 1150 degrees. So for you guys out there that are into latent heat and stuff like that, I sure would like to be able to get a hold of someone that could actually work out the wattage that's in this plate. I was looking at, and I was at the Mr. Plumber's today looking at and picking up my pipe. They had a 240 volt hot water heater regulated. I think it was 3,000 watts. It was just a puny little thing. It wasn't even this long, made out of 1/4 inch, maybe 3/8 pipe. And so, if you rolled that out, you hardly get nothing. That's just light duty pipe, not even 3/16 thick. So one of you guys out there, maybe, I'm just saying, work this out for me, because this is not, I don't have the smarts in that area. I like to build things and design things. When it comes to the technical aspects, I'll leave that up to others that are more technical than I am. So you have 96 square inches of 3/16 black steel pipe at approximately, say, 11 to 1200 degrees. So maybe one of you guys out there could get back to me on this and just give me a scale, a reading on the wattage that this would put out between 1100 to 1200 degrees Fahrenheit. All right. So there you have it, I think. 4.5 minutes. I've been talking to a lot of people around town on my travels on making this hot water heater using the joepipe technology. And, a lot of people, they were quite suppressed, especially the guy at Home Depot. I believe Jason's his name. No, Justin. and there's a couple other guys that I was talking to. And so once this is made on, this will be the top portion here. Okay, the green will be the top portion. This is going to be the side. So here I'm going to make cut out a 4 by 8 inch hole. I'm going to put some wrap the 1 inch perimeter with probably a blue skin. I need something that's double-sided for a seal. Then press the 16th inch plexiglass or Lexan plastic over top, and probably get some aluminum 3/4 by 16th or aluminum strips, and just use machine taps to screw it in, some self-tapping screws. So it's going to stand up to a few pounds pressure anyway. So what I'm hoping to do once this is made, and this is just the first, the introduction part of the, I'm going to call it the Cities of Light 1 quantum thermal generator. That's actually what I'm going to call this. I was looking at the, someone sent me a link on the QEG quantum energy generator, and I was quite impressed. And although this isn't a Tesla generator, when it does go into the quantum state, I believe that I'm replicating Tesla's work by creating the actual thermoelectric circuits themselves without the use of copper and magnetism. And that's why I went to call it the quantum thermal generator, or QTG. And so what I'm hoping to do with all this, I figure my wattage should be around at least above 10,000 watts, maybe between 12 to 15,000 watts on the using propane. And what I'm hoping to do is be able to run a modem heater. I believe it's 7 gallons per minute or 6.5 gallons per minute at 46,000 BTU, and be able to test one of those. If it works, then try it out on a 2,000 and 12,000 BTU modem heater at 16 gallons per minute. And if that works, this is going to make it very affordable for you guys out there that run oil. If you don't have to do oil anymore, you can go to hot water heat using the joepipe technology, and it's going to probably be, compared to conventional on-demand heating systems, maybe 200 to 300% higher. And the thing about the joepipe technology, you don't have to stay with propane. You can use natural gas, you could use alcohol, you could use superheated wood smoke, you could take any kind of waste oil or diesel fuel, and you can use the heat of the pipe. You can actually make a smaller joepipe that would plug into the back, and you could use a ultrasonic injector to spray in your fuel to super crack it, to volatilize it, and use that as your, feed your volatilized fuel into here along with the air, and that would replace the propane. So even this system here, using the propane, I'm just guessing maybe 2 to 3 ounces of propane an hour. And I did look around for a gram scale. I went to a co-op, and the best ones you had there were 11-pound gram scales. And I actually found, went down to Ferguson Supply in Charlottetown, and they actually had a 30-pound gram scale, and that's the one that I'll be using. And I've ordered a 5-pound propane bottle. So when I'm actually doing the tests, you'll be able to see the water heating up through the window, through the 4 by 8 inch window. You'll be able to see the formation of the bubbles, and at the same time you'll be able to view the watch how much fuel is actually being consumed, right down to the gram. So this is going to be a very specific. And as with most things, you know, like cars or whatever, and cars are very inefficient, maybe a third or less, and it's all in the efficiency of the system. And then, and then in the joe pipe heater system, that 100% of the heat, or I could say about between 1,000 to 1,200, 1,000 to maybe 11 or 1,200 degrees of the heat of the pipe is actually going directly into the water. Where the exhaust, when you take the heat out of the pipe, it's actually pulling heat out of the exhaust itself. Normally the joe pipe will produce 2,000 degrees of heat on the Fahrenheit scale, and by wrapping water around this, we should be able to measure the precise drop. And that way we'll be able to calculate the amount of heat being produced in the pipe, as opposed to how much heat that's left over, and together we can get a total BTU rating as far as the heat, as opposed to the heat of the exhaust, the heat of the pipe, as opposed to the heat of the exhaust. Okay, I'm going to end it here. And for you plumbers know out there, at a certain point, you like the QEG system. I like to be able to outsource this. So I'm going to do a preliminary test. And once the preliminary test, where I can get my basic numbers off, then I would like to go on crowdfunding there and put together a highly professional stainless steel system with all the testing equipment. Probably looking at maybe between $12,000 to $15,000. Let's put a system together which includes the testing equipment. But you can probably build one of these for under $500. And if it's 200 to 300% more efficient than anything is out there, it's going to drastically cut back on your heating costs. And the way it's designed, you can actually have a modine heater set right on top of the plenum here, or you could actually use this for an inline feed for in-floor heating. You could actually plug your circuits into here. The hot water will go out, and your cold water coming in through the back. Okay, it's the 9th of April 2014. This is the first installment of the joe pipe quantum thermal generator, the first series. And I'll probably have another 2 or 3 by the time I actually have the generator made. And the last part of the series will conclude in the actual test. I'll probably run a couple tests on it. This is Joshua Taylor coming to you from here on the east coast of Canada.